Hello and good evening, CSI258 Section 847 students for the second 8-week term of the Spring 2015 semester at Anne Arundel Community College. This evening's video tutorial is going to be on PacketTracer Activity 4.2.2.6, where we're going to be configuring frame relay, and specifically we're going to be configuring some point-to-point sub-interfaces. Now this is different from PacketTracer 4124, which preceded this, where we were just simply doing some multi-point interfaces, as opposed to the point-to-point interfaces that we're going to be configuring here. And so let's go ahead and jump in. We've got our addressing table, and we're going to slide right down. This topology should be familiar. This is actually the topology we were just working with, and we're going to be making some minor changes. As you can see here, it's actually calling out the point-to-point sub-interfaces, and this is what I had mentioned in the previous video tutorial, was that you can use a multi-point configuration where you're just simply using the physical interfaces, and you can actually use sub-interfaces, very similar to when we do router on a stick. So we're going to go ahead and create these sub-interfaces on routers 1, 2, and 3, and you're also going to notice that there's a slight difference here. Whereas before, when we did the multi-point configuration, we had all of our addresses or all of our router interfaces were in the same subnet. And so what we've done here is with our point-to-point sub-interfaces, you'll notice that each of the sub-interfaces is in its own subnet. There's a couple reasons for this. So when we do point-to-point frame relay sub-interfaces, this kind of addresses some of the challenges that we typically have in a multi-point configuration with broadcast and multicast traffic. If you remember, when we did the frame relay command and we were creating our static map in the previous video, we went ahead and put the word broadcast at the end, B-R-O-A-D-C-A-S-T. And what this means is this is going to give us multicast and broadcast support. And so that's why EIGRP came up and worked with no problem. And if we were to have put OSPF on there, we would have also been able to configure OSPF as well, because these dynamic routing protocols, remember how they communicate with each other. So 224.0.0.10 is for EIGRP, and that's where the multicast hello packets are going to go. OSPF 224.0.0.5 and .6, you've got the DR routers and the hello packets, right? They're going to go to these multicast addresses. And so it's critical that when you're dealing with frame relay, and frame relay, if you remember from the reading, is non-broadcast multi-access, right? So by default, frame relay is not going to broadcast for you. And so, excuse me, and so that's why you've got to make some of these configuration changes that we've seen. So in the multi-point config, we had to specify the broadcast keyword. Here you can see that the broadcast keyword doesn't show up anywhere in here, right? So where is it? Well, in fact, we don't need it because we're going to be configuring point-to-point interfaces, right? And so each interface is going to have its own subnet, and this is also going to address the broadcast traffic as well as split horizon. And if you remember from the reading, we talked about split horizon, where an update that comes in to a router interface, right, cannot be sent back out that same interface. So if router 3, and I'll put up a little note here, this is split horizon. So this is what split horizon is. Right, so router 3 sends a routing update down here to router 1, and router 1 receives it on the serial 000 interface. So we're going to say there's no sub-interfaces right now. So this is kind of like the topology that we had in the previous PacketTracer example. So that update comes into serial 000, and now router 1 typically, right, would want, if router 1 wants to send that update back out serial 000, split horizon is going to prevent that, right? So the sub interface is being created. We can take a routing update in on the sub interface, we'll say .2, and we can send that that update out the other sub interfaces. So if we had .4, .5, .6, so it's going to go out .3, and so this is another advantage to using the point-to-point sub interfaces in frame relay. All right, so let's go ahead, and that's a good background there to get us started here, kind of segue from our last activity. So I'm going to clear the screen, and we're going to go ahead, and the first thing that we're being asked to do here, very similar as to the last exercise, and actually let me get the router interfaces teed up here. So we'll pull up router 1, give us a little more room. Router 3. And we're going to get as much room as we can here. And router 2. And again, it's interesting that the frame relay is still a topic on the CCNA exam. It's actually been dropped from both the CCNP version 7 curriculum as well as the CCIE version 5 curriculum. So, but again, it's a great foundational technology that's going to allow you to take that next step. And when we start to deal with the CCNP material, what you're going to be looking at is DMVPN, Dynamic Multipoint VPN, which offers a lot of the same configuration challenges and a lot of the same nuances that frame relay does. So let's go ahead and we'll start here on router 1. And again, this is a great activity, kind of ease us into frame relay. And so we're going to go ahead and go from user exec to privilege exec and into global config. And I'm going to say, whoops, we're going to get into interface serial 000. And this is key. So if you think about when we do an ether channel, you do the configuration, you add the links into the channel group, but then you do all of the configuration under the port channel interface. And it's kind of similar here. So we're going to set the encapsulation to frame relay, and we're going to do that under the main serial interface. And then I'm going to say no shut. So we declare the encapsulation for frame relay on this serial interface, and this is going to be applicable to any sub interfaces that we create. So it says step 2, configure frame relay encapsulation on R2 and R3. So let's pull up R2 here, and we'll do the same thing from user exec to privilege exec into global config, into our interface, where we're going to say, and remember we could literally do encap or enf. And if I do a do show run, that's going to run the encapsulation frame relay command. So then we're going to say no shut. And now let's walk over to router 3, where we're going to do the same thing. So we go from user exec to privilege exec into global config, into the interface configuration mode, and we're going to say encapsulation frame relay, and then no shut. So it wants us to test connectivity. So let's pull the PC up here, and we already know what we're probably going to be looking at here, which is a failure to ping over to 192.168.30.10. And we're going to end up with that destination host unreachable. Because again, router 1, which we were just on, if I were to say do show IP route, you can see we don't have a default gateway, and we certainly don't have a route, a more specific match to the 192.168.30.0/24 network. Because again, we haven't configured EIGRP, and we really don't have any communications that are up right now between any of these LAN segments. So let's continue on here. So back onto router 1, it says configure the sub interfaces now. So I'm going to go ahead and exit out here. We'll say interface serial 0/0/0.2. And this will be the sub interface that's going to go over to router 2. And so here are the choices we have. And with sub interfaces, this is one of the things that you need to think about when and if you're laying out a frame relay network is, do I want this to be a point-to-point sub interface, or do I want it to be a multi-point sub interface? And so keep in mind that typically in hub and spoke topologies, you're going to be using a point-to-point interface, sub interface. Remember that they act just like a leased line. So the point-to-point sub interfaces are going to behave just like it was a point-to-point T1 circuit, right? And then each sub interface, right? Each point-to-point sub interface is going to require its own subnet. So again, remember before we had everything was just in one big subnet, right? It was 10.1.1.1, 10.1.1.2, 10.1.1.3. However, here, every single sub interface, and you can see it right up here, right? I'm on router 1. So for subinterface.2, my IP is going to be 10.1.1.1/30. My DELC is going to be 102. And then that's going to correspond and be in the same subnet as the subinterface on router 2, which is serial 000.1, which will be 10.1.1.2/30 with a DELC of 201. So we've got that in here, and so we are interested in doing point-to-point. And as you can see, it went ahead and said that the subinterface is up. So now we've already declared the encapsulation on the main interface, so we don't have to do that again. But what we do need to do is put in the frame relay interface DELC, and this says define a switched or locally terminated DLCI, DELC, right? And so we're being told up here that that DELC should be 102. So we're going to enter in 102. All right, so now I'm going to go into another sub interface. I'll exit out here and we'll say interface serial 000.3, because this will be my, whoops, sorry about that. This is going to be my interface, my sub interface for router 3. So we'll say point to point on that, and then we're going to go ahead and drop our IP address in here, and the IP address is going to be 10.1.3.2. and it is a /30, 255.252. And did I forget the IP address up here? I believe I did. So I'm going to have to step back there and take a look at that real quick. And then frame relay and my interface DELC is going to be 103. Let me do a do show run here. Let's make sure that I've got everything in order, and I did walk right by that. So interface serial 000.2, IP address 10.1.1.1, and this is going to be a /30. So there we go. All right, so that takes care of router 1. So let's save our config here on router 1, and actually I'm going to go ahead and we'll knock out the EIGRP component as well. So router EIGRP 1. And remember that those hello packets are going to be going to 224.0.0.10, and so we want to make sure that we're properly set up here. So we've got our point-to-point interfaces. Let's get our network statements in here. So we need the network statement for the 10.1.1.0 that we just added, and that was a /30, so it's going to be for a wildcard mask of 0.0.3. And then I'm going to do the same thing for the 10.1.3.0. I'm going to add a network statement in there. So let's do a do show run and let's see what we look like on our EIGRP config, and there it is. We've got our passive interface to the LAN segment. This was already supplied for us, the network statement for our LAN segment, and we've just added in our 2 frame relay sub interfaces, point-to-point sub interfaces. So now let's go ahead and save our config and transition over here to router 2. And so for router 2, we're going to use DELC 201 between R2 and R1, and 203 between R2 and R3, very similar to the previous exercise. So let's, we've already taken care of serial 000, and the frame relay and cap is on. So let's jump into the sub interfaces. So we're going to say interface serial 000.1. Oh, sorry about that. And we're going to do point-to-point there. So it's going to be a point-to-point sub-interface. And now that interface is up. Let's get our IP address on here, which is going to be 10.1.1.2. And it's a /30. So it's a 255.255.252. And we need our frame relay, interface DELC command on here. And between 2 and 1, it's going to be DELC 201. Now we're going to go into interface serial 0.3, and this is going to be a point-to-point interface as well. And we're going to say IP address is going to be 10.1.2.1, and this is a /30, 252. And now we need our frame relay, and I did 201, so this is going to be 203 between router 2 and router 3. All right, and then let's go into the router EIGRP1, and we're going to add our network statements in for these sub-interfaces that we just created. So this is going to be 10.1.1.0, and it's a /30, so 0.0.0.3 for the wildcard mask. And you can see the neighbor relationship came up right away with router 1. Now, is it going to come up with router 3 when I type in this command here? If your answer was no, you're right. And the reason it's not going to come up is we haven't actually configured router 3 yet. So if I were to say do show IP EIGRP neighbors, we only have one neighbor relationship, and that is with router 1. So that actually, whoops, sorry about that. Bring that back down. So that actually does it for router 2. I'm going to go ahead and say write mem. And now let's pull up router 3. Let's take care of the configuration for router 3 here. So do show run, we've got our encap set, and we're set to frame relay. It's been no shut. So we're going to say interface serial 000.1, which is going to go over to router 1. It's going to be point to point. And the first thing we'll do is the IP address, and so it's going to be 10.1.3.1, 252 because it's a /30. 10.1.3.1, and then interface serial 000.2. Is that right? It is. And then we're going to do point to point there. And I forgot the interface frame relay. Or the frame relay interface DELC. I'll step back a second here. So IP address is going to be 10.1.2.2, and this is also /30. And I left out the address there. And so let's also add in our frame relay interface DELC, and this is for subinterface 2, and this is going to be 302. Let's go back into interface serial 001 and add in the frame relay interface DELC is going to be 301. All right, so we've got that added in there. Let's round this out. Now you'll notice no neighbor adjacencies yet. So if I were to say do show run, do show IP EIGRP neighbors, you can see we don't have any right now. We have an EIGRP config set up with Autonomous System 1. You can see it right there. We're redistributing our static, which is set to the internet, and so that's going to be propagated throughout the Autonomous System 1 domain for EIGRP, and we'll pick that up on routers 1 and 2. So let's go ahead now and add in router EIGRP1. Let's add the network statements, and as we do this, 3.0, we should see the EIGRP adjacencies come up. And again, remember, we didn't have to put the broadcast keyword in here because we're not doing sort of a multi-point config with physical interfaces. We're doing point-to-point subinterfaces, and these again are going to act just like your leased line would act. So there's our adjacency between router 1 and router 3 and we got to do 10.1.2.0. Is that right? Okay, there we go. And now our adjacency comes up between router 3 and router 2. So let's go ahead, let's end here, let's do a write mem. Let me step over to the PC. Let's confirm our connectivity. We can see we're 100 out of 100, and we should have maybe one failure here while it ARPs to the default gateway, times out, and then we are good. But let's take a look at some of these commands here. Let's take a look at what does, and I'm going to stretch this out, the frame relay. We're going to look at show frame relay. And it's actually kind of nice because all of the commands are show frame relay, and then you're looking at basically three things here. The frame relay map, right? And so what do we see here? We see that we've got two subinterfaces, subinterface .2 and .3. Interfaces are both up, and now these are point-to-point DELCs. You see this here? Point-to-point. It tells us what the DELC is for that point-to-point interface. It tells us that it's supporting broadcast, and when it says broadcast, this also means, multicast, right? So it's supporting both broadcast and multicast. Status is defined because we defined it, and it is active, right? So all good stuff right here. And this is what you would be looking for. So let me go ahead and clear the screen here and take a look at our next command. It's going to be show frame relay. We'll pull the map back and just type in PVC. So this is going to show us our permanent, and sometimes you'll hear them referred to as private, virtual circuits. So it shows us the statistics for the frame relay DTE interface. We're active. We've got bytes that have come in and out, right? Showing the backward explicit congestion notification and the forward explicit congestion notification, the beckon and the fecken. And we'll be talking about more, we'll talk more about those later. And then for DELC 103, we get a lot of the same information. The status, PVC status is active, what interface is it, and what is the DELC usage? It is local, right? So it's local to our interface. So then we're going to go ahead and take a look finally at the local management interface information. And let me actually make this quite a bit larger here so that we can see what's going on, right? And it basically shows us for the serial interfaces that we have, what type of messages we're receiving, right? And you can see here serial 002, LMI type is Cisco, and we didn't change the LMI type. So let's do this. So I'm on router 1. If I wanted to go in and go into global config mode, and let's say I go into serial 000 dot, and I am going to need to shrink this now so I can see those subinterfaces, .2 and .3. And I think I've got those. Yeah, it shows serial 000.2. .3. I'm just looking at these here for a second. Wanted to see. So from the previous activity, when we took a look at the with the frame relay interface DELC, LMI, I'm drawing a blank right now here real quick, and it's not part of the encapsulation. Yeah, I'm actually drawing a blank right now on the command that I want to run, which is, no, I don't think it's here. Yeah, no, it's not there. And let me go to int serial 000, could be my problem. So encapsulation, frame relay. Yeah, so if I were to say IETF, right, if I were to change the encapsulation, and what just happened there, I was actually looking for something under the sub interface where it was on the parent, it's under the parent interface. So I'm going to change the encapsulation from Cisco, which is the default, which we just saw up here, right? You see the LMI type of Cisco. Let's go ahead and change the encapsulation to IETF, and then let's run that command again. Do show frame relay LMI, right? And so we still see that we have Cisco, even though, because again, we've changed the encapsulation, but we haven't changed the LMI type. And I'm trying to see if I can take these interfaces down. Frame relay map still shows active and up, and I wonder if we do a shut and then a no shut. And let's see what happens. See if we can get some frame relay map. So it shows Cisco still, and shows that everything is active even though we've changed the encap. So I was hoping that it was going to take it down so we could see what it would look like when the circuit was down. If I were to simply let's go into interface serial 000.3 and just say say shut. And now let's take a look at the map. Right, so here we go. So this is what it would look like when the interface is down. It would say administratively down, still point to point, but instead of active, it's inactive. And administratively down just simply means that it's been shut down. Just like when you do a do show IP interface brief, right? Administratively down, VLAN 1, means that that VLAN has been shut down by the administrator. And so that's what we see here. And again, I apologize, I was trying to think of a craftier way to get this to go down, and then just simply figured, okay, let's just shut the interface down and see what it looks like, or the sub interface there. Okay, so that is PacketTracer activity 4.2.2.6, and we basically had an opportunity to create some frame relay point-to-point sub interfaces, and then a couple of the key takeaways here. The point-to-point sub interfaces, they act just like lease lines, and each sub interface is going to require its own subnet on the router that it's on, right? So sub interface 1 is not going to be in the same subnet as sub interface 2. which when we were using the physical interface, that's what we saw previously. But that's not what we're going to see with the point-to-point subinterfaces. And then the multi-point subinterfaces. Those are going to act like non-broadcast multi-access networks, and they do not resolve the split horizon issue. The point-to-point subinterfaces do. And typically, you can use one big massive subnet like we did in the previous, the 4.1.2.4, where each of the 3 serial 000 interfaces were all part of the same subnet. All right, so that concludes this PacketTracer tutorial. I thank you for watching, and I'll see you on Saturday.